On October 25th, we're coming back to Melbourne for our first physical MLOps event. Whether you are just starting in the MLOps journey, improving in that space, or whether you have thousands of models in production, this event is for you. The type of things we're going to cover is MLOps for scale, and that scale can be number of models or the number of people in the team, or the number of prediction and inferences that need to be made in an hour or a minute or a second. So how to create effective MLOps for all those scenarios. We're going to cover MLOps processes and team structures. How do we organize ourselves and the talent that we have in our organizations for better results in MLOps? We're going to be looking at creating efficient and effective MLOps pipelines in an end-to-end. What does the data look like, the feature stores, all the way to the model deployment, serving, monitoring, alerting, etc. We're also going to cover getting a C-level buy-in and support for the investment in this area. We're going to be covering what governance and good management looks like in this space. So wherever you are in your journey, the MLOps event in Melbourne on October 25th is going to help you increase the maturity of MLOps in your organization. I hope you can join us. See you then.
I'd like to say a big thank you to our sponsors, Talent Insights. Talent Insights are Australia's leading specialist data recruitment business. With offices in Sydney, Melbourne, and Brisbane, they're experts at providing recruitment strategy and building data teams for clients across industries Australia-wide. They provide recruitment solutions for all roles across the data lifecycle, including data engineering, data science, advanced analytics, customer and marketing insights, business intelligence, data product managers, and data governance. They're skilled at finding the best permanent and contract hires for your business needs, as well as statement of work, project focus, data resources. At Talent Insights, relationships matter most. I can say from first-hand experience, Talent Insights are fantastic to work with. Whether you're a business leader within an HR network or a specialist data candidate, Talent Insights should be the first company you turn to for all your data recruitment needs. Find them at talentinsights.com.au.
Thank you so much, everyone, for joining our live webinar, first live webinar that we've had in a while. I always love doing these because of the audience interaction, the questions, and that definitely takes the discussion in the paths that you want, essentially, that you want to hear the most about. Today, it's all about MLOps, how to do MLOps with AWS SageMaker, obviously a super popular tool. It started off awesome, and it's made leaps and bounds over the last few years. So today, to cover MLOps in AWS SageMaker, we are very fortunate to have Romina Sharifpour. She's a senior AI and ML specialist solution architect at AWS. I was telling Romina before, I've known her for a long time. I've seen her present before. She's always great. So I know that we're in store for something super, super exciting today. And please forward all your questions about MLOps and SageMaker into that Q&A function. Romina, welcome. How are you going today?
Thank you so much, Felipe. I'm very well. Thank you. How are you?
So good. So excited. And excited to jump into the topic. I'm seeing a lot of poll answers coming in, actually. So we have, I want to say about 75% of people have answered the poll, which is excellent. And we're going to leave it open for another couple minutes. And what we're going to do is jump into the presentation. So we've got a presentation from Romina first, which is going to be about 20-25 minutes. During the presentation, come in with your questions on MLOps and anything she's covering, and I might interject with any relevant questions, and then we'll leave any others to the after the presentation, and that'll be sort of Q&A from there on, so we can cover the topics that you are most interested in, which would be great. So, Romina, if you can kick us off with the presentation, please.
Okay, so welcome everyone and great to see you all today. Felipe introduced me. I'm Romina Sharifpour. I'm an AI ML Specialist Solution Architect at AWS. And today the topic is about MLOps. So I'd like to start by talking a little bit about the status of MLOps we see nowadays, the challenges that generally we identify with MLOps. And from there, we will move on to tell you a little bit about Amazon SageMaker offering when it comes to MLOps. And I'd love to share a car sales story with you today. So Husnalwan is the head of AI ML, which I'd like to acknowledge him today as he wasn't able to join, but he's kindly has given me the permission and some of the slides that I can share with you to see what car sales is doing in the space. From there, I'd like to share a little bit on the key areas of success that I think help everyone and every organizations to successfully start looking in implementing MLOps. So if we're all ready, let's get started. So a little bit on the status of MLOps. One of the surveys conducted by Algorithma back in 2021, which is fairly fresh, indicated that most organizations have a long journey before they can deploy models into production. Only 11% can put a model into production within a week. 64% that form the majority, they take a month or longer. It makes you think, what makes machine learning deployment so different compared to software engineering, where some organizations have become so adept in it that they virtually send software within like just a few minutes. So one of the biggest challenges, I would say, is there's been so much emphasis within the past few years on the ML code itself, like that machine learning algorithm. However, as you can see on the slide, and it was also discussed extensively by one of the really famous papers by Scully et al. From Google back in 2015, the ML code is just really a small fraction of any machine learning systems. Around this ML code is infrastructure and sophisticated engineering processes that can really be complex, and you need extensive engineering effort to make this just work and make it to be an efficient sort of end-to-end process. There are other challenges unique to MLOps as well. One of them being the independency of data and code. In software engineering, we don't really deal with data. With machine learning, we have to constantly also think about creating the automated pipeline for our data engineering, and also make sure that our data quality is maintained. Within MLOps, we also deal with different personas. We have data engineers, we have data scientists, machine learning engineers, DevOps engineers, and a lot of the time these teams sit in silos. They do not really work efficiently together. Often adds quite a lot about the complexity within the MLOps, who owns what part of this end-to-end process. Other challenges is about experimentation and iterations, which is inherent in the machine learning work. And with that comes a lot of complexity around version control, tracking, and automation. With regards to the data and the model, we constantly have to ensure that the quality of the model and data are kept well. And we can put, of course, some automated tests to help us monitor some of that work. But a lot of the time now, we also hear a lot about the bias. We hear about whether our models are fair. So you start thinking about bias detection, whether your model is fair. And a lot of the time, beyond that, you need to involve the human in that loop. Finally, you go about a performant and a scalable way to deploy your model into production, which unfortunately is not the end of that process. You start thinking about, how can I monitor that model into production? how can I capture the data or concept rate? So as we can see, there's actually a lot into that sort of MLOps process, and it is a complex area. There's a lot happening, and there are different views on how MLOps should look like. So on this slide, I'm also sharing one of the recent work just published recently, 2022, by Kruzerberg et al., which they have actually done a very rich literature review. They've done also a lot of review of the existing tools, as well as conducting a lot of expert interviews to sort of bring together this picture, make it a little bit clearer that what is actually MLOps, what is involved in MLOps. And working backward from the principles, they've come up with a number of components, which more or less, I think, a lot of us can agree that these are necessary components. Some of it you might not agree, essentially, but they are the components that are often seen within the MLOps space. And also on the right-hand side, you can see the different roles and how these roles interact and overlap within an MLOps system. So like you see, it is complex, and most likely you have the thought of, okay, that's right. One way of doing this will not work for everybody and every organization. So I'd like to continue to talk a little bit about, after this introduction, what Amazon SageMaker offers when it comes to MLOps. So Amazon SageMaker Pipeline is a tool which is purpose-built and easy to use for continuous integration and continuous delivery for machine learning. SageMaker Pipeline, in a broad sense, consists of three components. So the first is the pipeline components. That pretty much helps you to create automated workflows easily for various machine learning steps. The second component is the model registry. It's a tool that helps you to manage various models and their version. And the third one is the SageMaker projects that allows you to incorporate the CI/CD practices when we design those machine learning workflows. So I touch on any of these components one by one in a little more detail. So the pipeline component basically allows us to build and create automated workflows using SageMaker Python SDK. The focus is really on orchestrating the task for machine learning model building activities. And typically, we see these steps to be, data preparations, model training, tuning, evaluation, and also potentially registering that model into a model registry if the model is satisfactory. So the second component, it's a model registry. And think about, many of you might have actually hundreds of different workflows with different versions of those models. So you actually need a mechanism to help you keep track of all these models, their version, and their status. So SageMaker Model Registry is a managed tool that helps you centrally manage model metadata for different model versions. Now, on the projects. So the final component is SageMaker projects that helps you incorporate the CI/CD practices. And by that, I mean automated triggers, source and version controls. They're some of the really core principles of CI/CD. And if you go to your SageMaker Studio to create a projects, you see that there are a number of pre-built templates available, and you find them to be for most common machine learning workflows. For example, one of the templates is only for model building. One of the templates is for model building, registering the model, and deploying the model. You found some of those templates also to integrate with the third-party tools, and that, such as, for example, GitHub or Jenkins, and that gives flexibility to customers who might not actually use SageMaker end-to-end. So you might be wondering, what are these actually projects? So these projects are basically CloudFormation templates that are created as a product within a portfolio inside AWS Service Catalog. You can think of them as a CloudFormation or configuration and resources as code that pretty much helps you deploy this entire CI/CD sort of end to end without actually the data scientists wanting to go and create it themselves. So this is, to make it a little bit clearer, this is an example of one of the projects. And as you can see, this project has two pipelines. So you can see on the left-hand side, we do have the model build pipeline. And on the right-hand side, we do have deployment pipeline. And I talked about the SageMaker pipeline as creating, that pipeline component or the workflow, which sits here. And you can see all of our machine learning sort of steps inside it. You do have the model registry that you register the model after the workflow is completed. And that if someone goes and approves that model, that creates a trigger which can start your deployment pipeline. So you can see the automation, you can see also the automated triggers. The other thing which stands out is that under hood of these projects, there are CI/CD tools that enable these projects to actually work. All those resources that I mentioned get deployed as a CloudFormation template, as a configuration and resources as code. For example, you do have the source code, AWS's code commit, that maintains all the code, the validated code for your machine learning pipeline. You have the code build, which goes to compile the code and builds this pipeline for you. You have the code pipeline as an orchestrator between the source code all the way to the build and deployment. You can see, again, the developer tools being also reflected in the deployment stage. And when you look at this, perhaps one of the areas that you think about is that, okay, under the hood, there are developer tools. What does that mean? It means you do actually have the flexibility not to run this project inside the SageMaker. If you do have those personas, for example, machine learning engineers who want to have the ownership, they can pretty much build this and control this within an account, not inside the SageMaker Studio. But SageMaker Studio gives you the leverage of the data scientists to be able to launch all these resources without actually themselves wanting to create it, which can be, the infrastructure side, can be the area which is generally not familiar for the data scientists. And like I mentioned, MLOps can actually be a lot more sophisticated and a lot more complex depending on where organizations are on maturity curve. But I suppose from a design perspective, you want to be able to create more complex orchestration and add components that are required for some of the projects. For example, here, as you can see, we do have an automated feature engineering pipeline. We do have a feature stores, which those features get fed into the feature store. You also see that we do have clarify jobs that SageMaker Clarify helps you to detect bias. You can also see that we have the model monitoring enabled and the data capture for that model monitoring, so that if the data drift happens, it will generate an alert, a CloudWatch alert, and it can be also a trigger to retrain your build pipeline. So you can see you can go ahead and build a lot more complex, orchestrations and pipelines because you do have that full visibility and flexibility by putting these components sort of together and workflows in a way that work for that specific project. One other area that I think is very important to allow you to successfully scale MLOps is really about enabling various personas with different skill set and try to remove those blockers from their way when they actually want to work together most effectively. And this can be in form of really removing that complex, unfamiliar DevOps part from a data science, plate, and in turn, letting ML engineers taking care of, the infrastructure in that. For example, you can find multiple personas and roles attached to those personas. So, for example, you can create machine learning engineers assigned to your machine learning engineers who are responsible for provisioning the project templates and all the CI/CD resources. Data scientist role can be your data scientist who are in charge of creating the machine learning pipeline that pretty much ends with a trained model registered to the model group. That will trigger and run the deployment pipeline without your data scientist wanting to do anything about it because it's automated. And that's why perhaps makes these transitions a lot more smoother between the team. You can also think of having an approval role such as the lead data scientist who has more access and more control over different environment. For example, they can go and have a look to approve the model from the model registry, which kicks the deployment pipeline, or within the UAT account or from a staging account, they can manually approve that model to go to the production. So as you can see, you can try to bring these teams together closer by utilizing the automations and the tool that can work for everybody. So the next section, I want to talk about a little bit on how car sales actually is using Amazon SageMaker to scale AI in their organization. So a little bit about car sales. I think we're all familiar with car sales, but they own a portal which facilitates buying and selling of cars for private as well as dealers. And they have around 160K Australian cars with 3,000 cars roughly coming every day. Apart from cars, they also have bikes, boats, trucks, caravans, and they also have presence in USA, South America, as well as South Korea. Car sales has been building and productionizing AI techs for many years. And they do actually have a lot of AI models, such as automatic ad approval, recommendations, and so on and so forth. But to just give you a little bit sense of the scale, a lot of their AI models can process millions of photos daily in real time. So with the car sales back in 2016, all the end-to-end workflow from experimentation all the way to end of the production was actually performed with the AI team. And it was consumed then by the developers. But as you can imagine, that can be a bottleneck because AI team is small and there's just much that a small team can do for the entire organization. So further in 2018, there was a data science team that was added that they started to take care of the experimentation. But still productionization was performed by the AI team. Still, you will be limited with regards to, which of those experimentation can get productionized and use case because of lack of resources, not enough resources that might be out there. So moving into 2022 and the new strategies, particularly around the democratization of the data science and ML engineering skills within car sales, every developer can actually go through this end-to-end process themselves without needing data scientists or the AI team. The other workflow is also having the developers to pair with data scientists for the more sophisticated machine learning problems. So let's see actually how that works. So from architecture perspective, car sales call this CIA, is the Car Sales Intelligence Academy, which consists of two components. One component is the orchestration layer, which is built using Metaflow. that allows to build continuous model training pipeline. And you can actually use any orchestration tool, and I see customers use different ones. Sometimes they use Airflow, sometimes it might be a step function, but like I mentioned, you can use SageMaker pipeline as well that I talked to earlier. So Metaflow is similar to that in that sense, is an orchestration tool for your machine learning steps. And the continuous training pipeline pushes the model into the deployment module, then can deploy the models for inference. So the continuous model training is really just a Python script that you pass on. So it's really up to you how you're going to build a model. Whether you want to use TensorFlow, whether you want to use scikit-learn or PyTorch, you just need that script. And car sales using SageMaker built-in algorithm that is collection of algorithms that solve for very common machine learning use cases, such as image classification, XGBoost, sequence-to-sequence model. They actually democratize the data science skill for the developers. Working with these algorithms are very easy. You don't really need extensive machine learning knowledge. You can just write few lines of code and get these models to work. So that gives ability to the developers to actually build the models themselves. So that's where the democratization of data science skills become available to everyone in the organization. And a lot of the time, 70% of ML problems can usually be solved with one of these inbuilt algorithms. And the rest 30% that require the custom build models, that's the time the data scientist will step in. And for them is a trifecta win-win situation, because data scientists love to solve the hard challenges, not the generic one. The developers get to actually learn and do machine learning. And business also scales the production of this AI system very cost effectively. So that's about how they've gone about democratizing the data science skill within car sales. And then focusing a little bit on the deployment side. So deployment happens on Amazon SageMaker. And Carcel realized that they actually need flexible deployment, and it actually is very helpful to have flexible deployment option. And that's what SageMaker could provide, in a sense that you can deploy models into real-time endpoint with one line of code, really .deploy. And that helps any developer, without being a machine learning engineer, to be also able to ship their models into production. And that is about also, the flexible inference option, as well as democratization of machine learning engineering within car sales. The other aspect is about when you actually open to everybody to build their own models, there will be a new challenge happening there. So how do you avoid one team going and build a model that other team have already built it? How do you actually maintain that traceability and visibility of what's been built, what's been deployed? And that's where car sales use SageMaker model registry and they have a central model registry which maintains the registry of all the models and their version. And before someone go and build a model, they can go and search and see whether a similar model or the model have been built or not. So that's how they also utilizing the SageMaker model registry for cataloging their models across the organizations and teams. So sort of to wrap up with the car sales story, this is how they could overcome some of the challenges to scale up their their AI costs really, their AI really cost effectively. And there's still a lot that is happening with the team in this space. but they are already seeing some benefit out of this. So recently, one of the development team with really zero data science and machine learning engineering skill built and deployed an image classification model in just 5 days with CIA. Without the CIA, it would take a team of machine learning engineers as well as data scientists, which they have the knowledge and expertise, 2 weeks to complete the same task. And this is just the beginning of the journey for Parcels. And I'm really looking forward to see a lot of more great stuff that the team are doing. And I'm really looking forward to see more of that as we move on. So that was also the story that, again, Gus wasn't able to be here. I hope I did it justice telling about their story, but I just want to wrap up with some of my observations and some of the areas that I think they are key for being successful with starting your MLOps. So first of all, building MLOps is a journey, and it also is really about culture and technology working together. So build a culture that allows you to continuously nurturing and developing over time. Start small and then build on top of that to create more complex workflows and processes. Identify goals and strategies really early on. Components of MLOps that are important to you, the roles, the skill sets that you've got in-house. We know nowadays that there's quite a lack of expert skills in some of the roles, we visited before. So think about how you can actually work around all those limitations that you've got before going and doing something and then realizing that you do not have the resources to actually do it or implement it. There's also a need for a cultural shift away from this model-centric machine learning. And we actually hear quite a lot about this nowadays. We hear about, data-centric AI. So it's a little bit of a shift in a way that different teams think about machine learning and how machine learning can actually be deployed. Every organization, I think most of organizations, they have already some processes and some tools with regards to DevOps practices as well as orchestrations. So early on, start investigating all those areas, all those tools, all those practices, and see how you can integrate with those. That's always helpful in a sense that you will have lots of also buy-ins from the people who already are familiar with those tools, are using those tools. There is no one valid approach to MLOps that everyone agrees to. We all have our different views, and that's entirely fine. And I think it's valid because an MLOps architecture that might work very well for enterprises might not actually be something very good for a small team or maybe a medium-sized team with multi-account sort of a strategy. They might have also different requirements with regards to those accounts. So think about what your requirements are again and build around those with regards to what MLOps will have to look like for you. One other area which, again, open to debate is that model deployment and experimentation is not really part of the MLOps. So I would suggest to create an account, let your data scientists to experiment, to develop models. Once out of all those experimentations, you have a validated model, that's the one you want to put into your automated workflow and build CI/CD around that. You can think how overwhelming it can be that every single experimentation that data scientists do without it being really useful or in any way. If you want to start from that beginning, keeping track of all those, you can start thinking how overwhelming and complex can be. So I would definitely suggest try to separate out the experimentation as well as model development from your MLOps. Let MLOps start with the code, the seed code of that validated model that can be automated in your CI/CD. And finally, try to scale MLOps practices across your team as much as you can by using automation, managed orchestration that helps removing those heavy lifting. And also, once you have less management work to do, you will see your teams to be able to work more closely together. So try to bridge those gaps as much as you can. So that's all for me. Thank you so much.
Romina, that was excellent. Thank you so much. What we'll do now is we'll review the poll results. I'll get your thoughts on those answers. So I'll close the poll now, and then we'll go into the audience questions, which we have heaps on, which is great. The engagement has been incredible. People are super interested in this topic. So let me share with everyone the poll results. They should be popping up on your screen. So first question was, how long does it take your team or organization to put a model into production? We can see the split there with 44% of people saying longer than a month, and then 24% of people saying about a month, and then it starts to decrease. 14% of people said a week, actually, which is very nice. Any thoughts on that distribution, Romina?
I'm thinking some of it is actually similar to the very primary stats I shared. So,
which is great that like in Australia, we're seeing similar development.
Exactly. And I think I'm actually very happy to think that, percentages within a day and a week, that means the needle is really moving. It's moved. And I think that's what we want to see. So it's amazing. It's good.
Right. Yes. We asked a similar question in a webinar about 2 years ago, and the distribution was much more skewed towards a longer time frame, as you can expect. So that's excellent. We're getting some nice messages of people saying that they really enjoyed your presentation. So Carrie says, thank you for the awesome presentation. It was super informative and useful. And Jason says, really enjoyed your insights around keys to success as well. Thanks, guys. Question 2 was, which stage do you find the most difficult part of MLOps? This was a multiple choice. So we have the data quality as the leading one with 44%. And then there is model monitoring with 38%. Very interesting. And then there's a couple at 30%. Any reactions to that spread, Romina?
Yeah. So a lot of the time, some of the discussions I have, and I talked a couple of examples on that, the data access can be a tricky one for the machine learning. And a lot of the time within organization, you do have multiple accounts. So you have development account, you have a staging account and production account. A lot of the time, the real data, the actual data sits inside production account. So a lot of the time I found myself having this conversation with the customers that allowing data to go from production account to the development account for the data scientists to actually see, experiment, and develop models can be a really, really sensitive area, can be a very tricky area, especially depending on the type of organizations and the type of data they actually work with. So that, I think, can be a very deep area in a sense that a lot of the time you need to start by educating a lot of the stakeholders in a sense that if you provide synthetic data, if you provide just a small sample of the data scientists cannot work. This is not really the best recipe for building machine learning models because and a lot of the time, if that happens, the customers end up having two pipelines, pretty much. One that runs within that development account, and it's purely a functional pipeline. It's not a well-validated model because it's not using the actual data. It's just using the synthetic or just a part of the data. And then the other pipeline, that is the actual one and feeds with the actual data, sits within the production account. That can be tricky in sense of how do you provide access to these data scientists because they need that data. So I think a lot of the time in those areas, you start by actually educating some of the internal stakeholders on provide data to to data scientists. However, you can have all the guardrails that you need in sense of how to secure that data, maybe categorizing that data based on the sensitivity level, provide just read access or a replicate of the data. So those are all the discussions that can be quite deep within organizations a lot of the time. But at the same time, I think the key to successfully build machine learning models is actually working with real data.
Yeah, definitely the case. And we had a related question from Charles, actually, that he says, handling personally identifiable information, so PII, and personal health information, so PHI,
Yes.
to handle those, you generally need VPC endpoints in every component of the pipeline.
Yeah.
He was asking essentially how that works in AWS, if you have any suggestions on how that can be done, or if there's an alternative like de-identifying the information but having it still similar between dev and prod.
Absolutely. So the good practice is when it comes to machine learning, regardless whether it's on AWS or anywhere else, you have to anonymize your data before using it for the model. So that's number one rule. And I definitely recommend that. Anonymize your data. That's number one. When further down, then you need to have tools with regards to the data encryption at rest and in transit. Those are the tools that AWS provide within the machine learning, within the SageMaker. You can always encrypt your data on your S3 bucket or where you actually, where your data is in transit. Further down, the VPC endpoint.
That's great. So dropped.
Exactly, no worries. Within SageMaker, the good practice is that SageMaker Studio has to be launched within a VPC, within a private network. That doesn't allow your data to traverse in the public internet and then comes back again to your account. So that is enabled with the VPC configurations that you're able to do. And when we run jobs in the SageMaker, we run them in those remote instances, and using the tools again like Elastic Internet Network, you can add those configurations to whatever jobs you run, and ensuring the security of the training as well as deployed jobs within the SageMaker environment.
Excellent. Thank you so much. We'll wrap up the poll question. So the last one was question 3. Have you incorporated CI/CD practices into your ML workflow? So the distribution is pretty evenly spread. So 30% said not yet, but planning on it and getting close. And then we had 27% with no, we haven't incorporated CI/CD practices into our ML workflow. And then 24% with yes in pockets of the business, and almost 20% with yes, we have. Any thoughts from your side, Romina, on this split?
It's quite of a spread. So 19% says they have. Yeah, I think a lot of the time, actually, organization might have something in place. You find actually different challenges. So I saw model monitoring being one of the significant one, and that is true. Yeah. Model monitoring, if it's done manually, it can be a very difficult task in terms of setup and in terms of, how it should be implemented. So to that, for example, if there are some tools that can make that easy for you, that's something definitely you have to consider. And by CI/CD, sometimes those pipelines might be just the very simple pipelines. But when you start thinking about more complex workflows, I think that's the time you start also identifying new challenges. How I'm going to ensure, of the bias that is captured in the data and the model monitoring being one of the really big ones that we hear a lot about. And if you're interested, you can definitely explore SageMaker Model Monitor. That actually makes that quite a lot easier. And And also, if you want to, feature store is another one that we actually hear about. It's a good addition to the entire machine learning workflow. So a lot of the time, once you start expanding a little bit, you might find, challenges, along the way. But I think it's really good to see that there is actually workflows and CI/CDs within many organizations. So I think it's really positive to see how they can build on that, expand that, and being really flexible in terms of how those workflows are designed.
Oh, definitely, right. I'll stop sharing the polls now, so we'll close that and we'll jump into the audience questions. And related to what you were saying just then, it was impressive to see that in SageMaker you can do the feature ingestion and the feature store. You can do the model building and retraining. Then you can do the model serving, monitoring, the whole end to end. So that's really great. And we had some questions related to that. One of them, which I thought was interesting, came from Greg, and he asked, what does the SageMaker support look like for non-technical business owners to be involved in the process and help govern? And this can be at a model level or a data level. What does that look like in SageMaker?
Yeah, awesome. That's actually a very good question. And I like it because I really like to hear about empowering anybody in organization to get hands-on with the machine learning work. So on that, SageMaker has recently launched SageMaker Canvas, which is a fully no-code environment for any personas who want to validate their use cases, but they don't want to code. Sometimes even I'm a data scientist, but I feel like no code. I just don't want to code because I want to do something really fast. So SageMaker Canvas is a no-code offering which sits in a separate IDE as the SageMaker Studio. And you just use the point and click to get in your data and then pretty much build a model, validate your idea, make prediction of it, do what if sort of scenarios. And if you think that model is valid, if you see values, then I think the great thing is about it, you can just share that model with one click into SageMaker Studio. That's where you can start collaborating with the data scientists. So data scientists can go and see that model, and then you can discuss whether you want to improve that model, you want to tweak it, what do you want to do moving forward? You want to take it to production and then plan on top of that. But important is that any persona is able to validate their ideas rather than wanting to be blocked by a data science team, which they have lack of resources. They can start experimenting and trying their ideas. With regards to the governance and with regards to the visibility, especially for the stakeholders, especially for some of the audits and compliances, there are also tools available, capabilities available inside SageMaker. So I mentioned about SageMaker Clarify, which is a tool that helps you to detect bias and also explain the behavior of the models. When you use these, it generates actually very nice reports for you, like PDF reports, and explains all those scientific, bias metrics that some of them might be really interpretable and useful in your case, with examples that you can directly share those reports with the people who are doing the governance jobs, who are in compliances or audits, and they can read them and they can understand. They don't get exposed to the code really because they don't want, most likely, but they see the report generated out of those, that they are actually a very nice, I think, way of sharing what was found when we did this bias analysis, what areas need action, or otherwise it's just good. We can go ahead with that. So a lot of the capabilities that require other people to look into, such as, audit, for example, they generally generate a report for you that you can actually share with the relevant stakeholders, and it's easy for them to understand as well.
Super powerful. That's great. Thank you so much. And also related to Greg's question and related to a comment we just had from Visha, the common thread there is around becoming more data centric.
Yes.
So there was something that you mentioned towards the end. I thought maybe it'd be good to circle back on that one. I'm a huge fan of the kind of like expansion of AI from model centric to data centric as a next evolution. So the link from Greg's question was, when people are involved in the governance aspect, could they see, for example, SHAP values of the data set, the data points, to identify labels that could be improved or anything like that? And then the link to Licia's question is whether you can expand on data-centric and the shift that's happening there.
Absolutely. So with regards to the SHAP value, SageMaker Clarify is empowered, actually uses SHAP value, optimized SHAP value for explanations of the model behavior. And you can do that at global level, as well as you can also extract individual cases. So the report, the generic one for the explanations of the model behavior, that PDF report that I mentioned actually gives you the SHAP values with all the contributing factors and the relative importance with regards to that response variable. And if you feel like you want to dig into some specific cases, you can use the APIs to also generate the SHAP values for that specific cases. But under the hood, absolutely, it uses the SHAP values for the explanations of the model behavior. With the bias metrics, the scientific papers are actually available online, so you can actually have a good read about them. There is extensive list of metrics that some of them are really thought-provoking in a sense that a lot of the time detecting bias, it can be a very challenging work, right? So I think, but when you read the examples, you can identify which of those metrics can be really useful in your given scenarios, in your given case as well. With regards to the data-centric, so back in time, like I said, and perhaps when even I was really hands-on data scientist, there was lots of emphasis with regards to the model. And we tried to improve the model pretty much with the same data, but with optimizations, whatever way that you could think of, the hyperparameter optimizations, to get that model to perform better and better. And a lot of the time, with feature engineering, for example, being another one. But the major improvements that you get is really it. But with the data-centric approach, the emphasis moves from the model into actually providing and feeding constantly more data to this model. Try to improve the model, not with changing the algorithm essentially and getting the algorithm to just do better magically, but when you start feeding more and more data to the model, improving the quality of the data constantly, and that feedback loop, that's where it's a paradigm of data-centric approach to machine learning. So shift the emphasis on building these automated workflows that can provide that data constantly to your model, so your model can improve with the new data that feeds to it rather than just the algorithm itself.
Awesome. That is a fantastic explanation of data-centric. Thank you for that. We had a couple of questions on visualization within SageMaker, and we had one really interesting from Elma, where she was asking whether in SageMaker you can get visualization to understand and compare the model performance and essentially how a bit of the inner workings and how they're performing.
Yeah. So with model performance, I can think of a few different things because model performance can also apply in different stages. With regards to when you train a model, especially very complex models, deep learning models. So a lot of the time, the performance of that training run can relate to the infrastructure that can be actually a tricky component within that MLOps that I showed you and based on the paper, because when the model changes, the underlying infrastructure, how does it have to understand that I need more GPU or I need more CPU? So with regards to that, the training performance in sense of to ensure that, for example, that deep learning model is converging well, the gradients are not vanishing or they're not exploding, or the resource utilization from infrastructure point of view, we do have SageMaker Debugger. So SageMaker Debugger helps you to debug the training runs in a sense that you make sure to capture bottlenecks with regards to the infrastructure, CPU, GPU, memory usage, and so on and so forth, but also debug the training runs with regards to the model that you're building. A simple model such as XGBoost, you want to see that the cost function is, for example, decreasing. With the deep learning models, you want to look at the gradients to make sure they're not vanishing or they're not exploring, and so on and so forth. There might be different rules that you can use the SageMaker debugger for. That's with the performance within the training. The performance of a model that is in production, that's a different story. And there are multiple areas which we can go really deep into them, but in interest of time. One is about, from a latency point of view, how the model is performing in production. And there are also tools available like auto-scaling to make sure the model can handle the traffic that goes to it. From the quality of the model monitor can help you to capture percentages of the data or all of it if you like, and compare it to the ground truth labels that you define as a baseline job. And you can have a trigger issued for you via the CloudWatch that says your model accuracy is dropping based on the ground truth that you've showed me and based on the model new predictions that is actually generating. So as you can see, there is lots of considerations, but depending on where the focus is, we can definitely think about architecting a resilient and a solution that helps you be optimized.
Awesome. Thank you so much. I know we are almost out of time, which is crazy. We've covered so much ground, and there's a lot of unanswered questions or outstanding questions that we have from the audience. So what we're going to do is we're going to continue the conversation in our Slack community. So I've just posted the link to the Slack community on the Zoom chat. Please join the community if you haven't done so yet. There's about 250 people in the community already. So hopefully we'll get a few more after this session. And we'll ask Romina to join the community as well. And what we're going to do is post the questions in each question in an individual message. And we can continue the conversation in the thread of Slack. So that way we don't miss out on any questions or answers. We don't miss out on any of the goods. And some of the remaining questions are looking at reproducibility and tracking the full lineage of the model, including the data. We'll have questions around Bayesian packages. We have questions around data quality, integrating that into MLOps. A couple more on the visualization side, questions around experimentation, etc. So we'll put them all in the Slack community. I hope to see everyone there so we can continue to share the knowledge and get everyone's questions answered, which is what we're here for. So with that, Romina, thank you so much. We're getting so many great messages about how much people enjoyed your presentation and your answers. They're saying really informative presentation, love the discussion. And Jason said, didn't know much about AWS SageMaker, but I do now. People were saying, great event, great session. So thank you so much, Romina. Thanks everyone who joined. And thank you for coming today. Thanks for making the time. I hope that you come back soon.
Great to see you all as well. Thanks, Felipe, for organizing and having me.
Oh, thank you so much. Thanks everyone. Have a great day. I'll see you all soon.
Thanks for watching this video all the way to the end. I hope that you got a lot out of this discussion. And if you're watching on YouTube, please like and subscribe to the channel so more people can find out about the challenges that leaders have in the analytics and AI space. And that's what we're trying to share in Data Futurology. So please like and subscribe. And if you enjoyed today's episode, please tell your friends. Thank you so much.